Hello everybody. What we're getting into today, so the third section of chapter 3 is polynomial division. So to recap what we've done so far, we've been analyzing graphical characteristics so far of both quadratic equations and also higher degree equations. Now what we're going to be going into more specifically is how do we find the zeros, which are a review from last couple sections, or the intercepts. How do we find these for any polynomial? And what we're going to notice today is that a lot of the ways that we do this relates back to things we've hopefully done all the way back even to elementary school with long division and things like that. But what we're going to start off with, this first example. So division is the whole basis of this section. First thing, what we are doing is taking this polynomial, so this is in words. So again, in your notes there, jot this down. Let's see, so in this case, this polynomial by 2x. So a good review of terminology anyway. Dividing by a monomial, a single term. So terms are separated with addition and subtraction. So that is a single term, nothing is added to it. When we divide by monomials, the process is fairly straightforward. All it really breaks down to is reducing fractions. So all I'm going to do, just the wording, divide this polynomial by this. That means 2x is the divisor of our division. So what I do now, I can really just create, you can kind of visualize it, 4 separate fractions. So I'm going to take 2x to the 5th divided by 2x. Take the next one, also divided by 2x. So again, this is a fairly straightforward process, any monomial division. So all I do, left to right here, 2 divided by 2 is 1. X to the 5th divided by x2, you can think the first power, we subtract exponents, that would leave us with 1x to the 4th power with the first term. And again, I'm just going to keep on moving left to right and reduce individual fractions. 4 divided by 2 is 2. X to the 4th divided by x is x cubed. Next, negative 7 divided by 2, I'm just going to leave as 7 halves. X squared divided by x is x to the first power. Okay. Last part, 10 divided by 2x would be plus 5, and then leaving divided by x. None of these are like terms. This is our simplified quotient final answer to a division problem. So again, monomial division, very straightforward. All it breaks down to is simply reducing fractions. That's it. Next part. Now we're getting into how do we divide by more than just a monomial? And then what this stems from is simply long division that we've used all the way back to whenever you learned it. 4th grade, I'm not sure. But when dividing by more, also leave this method for now, nothing to worry about there. When dividing by more than a monomial, we use long division. So monomial division, again, single term, just reduces fractions. What we're going to review here is the simple algorithm for how do we long divide with just numbers, what you've learned in the past. We'll do 147 divided by 6. First of all, some important terminology, and this applies to any division problem. Doesn't matter that these are just constants compared to polynomials. The number that is being divided, hopefully a review, this is called the dividend. So in this case, 147 is the dividend of our division. That would be the numerator. The denominator is 6, also known as the divisor. So again, just two terms to know there. The final answer is called the quotient, which we'll get to here in a second. So to do the long division algorithm, here's what we think. How many times does 6 go into 1? Evenly. The answer's none. Then I move on, tack on the next digit. How many times does 6 go into 14? And the answer to that is 2, because 6 times 2 would be 12, not yet going over 14. So I fill in a 2. Then what I do to finish the division, 2 times 6, like we just said, is 12. and we subtract that from 14. 14 divided by 12 is 2. Next part of the algorithm, we take 7, the next term that's there, we bring it down and we ask the same question. How many times does 6 go into 27 evenly? And the answer to that's 4. Because 4 times 6 gets me 24, subtract them, 27 minus 24 is 3. Now, once we get there, that is called the remainder. We have no more terms to bring down with our division. So in this case, 3 is the remainder. Okay. So if 6 were to go into a number evenly, that would mean there'd be a remainder of 0. 7 is an odd number at the end, so I would have known that wouldn't work at the beginning. And then 24, the answer to a division problem is quotient. So make sure you do have those terms down, and that does apply to any sort of division that we're going to do. Moving on, let's see how this applies to dividing monomials, or I'm sorry, other polynomials. Okay. So next, use long division. Use long division on polynomials. Okay. So here's what we're going to do. First one, divide x squared plus 4x plus 3 by x plus 1. Okay. So again, we are now dividing by a binomial. 2 terms, x and a plus 1. So it doesn't work the same way as just simply reducing fractions like we did in the last one. However, what we're going to do is translate what we just did in that last review example to what we're going to do now. And I think the same way. Here's how I like to go and think of the visual. What multiplied by x gets me to x squared? And the answer to that is just x. So that's where I start. X times x is x squared. Now I also have to account for this second term now. X times 1 is plus x. Okay, so again, the same process is going to apply here, just like we did in the last one. Once we get to this step, we are going to have to subtract this from this and see what we're left over with. Now, really important thing to note here. That minus must always be distributed. Okay, so that minus must get distributed to both. So again, this would be, just to kind of visualize it, what this becomes then, x squared minus x squared cancels out. 4x minus 1x would give me 3x. Okay, so again, 4x minus x, 3x. All right, now we continue the process. I drop 3 down, same algorithm. What multiplied by x gets me to 3x? That's just a constant. It would be 3, so I have now a plus 3 up top. We do the multiplication again. 3 times x is 3x. 3 times 1 is plus 3. So what you can hopefully see right now is we're subtracting exactly the same thing from itself. 3x minus 3x cancels, 3 minus 3 is 0. So that leads us to a remainder of 0, leaving us with a final quotient then of what we divided there. X plus 3 is the final answer to our division there. Okay. Next one, we'll do one last one here with long division, and then we move into what the shortcut is. Okay. Second one here, x squared plus 3x plus 5. I'm sorry, we're going to do a different one. X cubed plus 2x plus 1 divided by x minus 7. So what I would encourage you to do, try this right now on your own. Pause it, see if you get to the same final result that I do. Moving forward though, this is just written a different way than this is. We can set it up that way. Just remember, this always becomes the divisor, the part on the outside. and on the inside, x cubed plus 2x plus 1. Now, before I write this, something that is going to be very, very important to always remember. Notice how as I go left to right, I'm missing an x squared term. I go from x cubed down to an x to the first power. Now, something that's going to be very important is that anytime we are missing a power, you must add in a placeholder of 0. So notice I put in a 0x squared. It's not here, but you're going to see why this is important to keep our terms lined up when we do our multiplication and subtracting later on. Then I just continue on. Plus 2x plus 1. Okay, so remember, off to the side, make sure we fill in 0 placeholders when needed. All right, so 0x squared because we were missing that in the original. Now we do the same thing that we just did in the last problem. So what multiplied by x is x cubed? The answer to that is x squared. All right, x squared times x is x to the third. Of course, why we picked it. X squared times -7 is minus x squared. So you can see now why we needed to add in that placeholder. Otherwise, we would be subtracting a squared term from something that was not like. X cubed minus x cubed cancels. 0x squared, and careful here, this is going to become minus a negative, which is plus. 0 plus 7x squared is 7x squared. Move on, drop the 2x down. Now I think what multiplied by x is 7x squared, and the answer to that is 7x. So I add on a 7x. 7x times -7 is -49x. So once again, do the subtraction. 7x squared minus itself. 2x, once again, we'll get minus a negative to be plus, and that gives us 51x. Now we have one final term to drop. Okay. So now we divide into 51x plus 1. What multiplied by x is 51x? The answer is 51. 51 times x. 51x. 51 times -7 is -357. Okay, so -357. So next thing, 51x's drop out. Minus a negative once again becomes plus, and 1 plus 357 at the end is 358. Now, important way that we have to make sure we remember to write the quotient here. Okay. So, we have our quotient. This one we have a remainder on. Now, you cannot simply write a plus 358 at the end of the problem, because then that would make it seem like we can add that to this 51, and that's not the case. So what I have to do to finish off my final answer, first part stays as is, so x squared plus 7x plus 51. The remainder must always be written this way. 358 over the divisor, the x minus 7 in this case. So again, the full remainder when we divide polynomials must be rewritten over the divisor. Okay. So again, there's long division. What we now have is a shortcut to that. So I guess what I would say is if that clicks for you, you use it. This one I think you'll find is much quicker. All right, so next part, the shortcut to long division. Which is called synthetic division. So again, essentially you pick what you want. Now, what I'd like to do here, just to refer you to the method over here. Okay. So jot down this method, have you pause the video here. So along in your notes, before we get into the first example, these are going to be the step-by-step rules that we're going to follow with how do we use synthetic division. I think you'll find it flows very easily. It's very quick. Again, now that you have the method jotted down, here's how synthetic division works. Divide x squared plus 6x plus 4 by x plus 1. So this is the exact same type of question we would have asked, both with the monomial division and also with the long division steps. It's just going to be set up a little bit differently. Okay, so here's all we do. The first thing, maybe this will look familiar to some, this setup. All right, now think of the divisor still kind of being on the outside. In this case, it's the x plus 1. However, we're not going to write that. All we're going to be using are the coefficients from our problem. So the way that I find out what number goes here, it's going to be a -1. Here's why. If I go back to this method here briefly, I have to use the divisor, which was x plus 1. I have to use that to find what is called the root, or the zero, or solution, as we've talked about in different sections, the root of the polynomial. It's as simple as thinking what number added to the 1 there gets you to 0, and the answer to that is -1. Okay, and again, that's what we're always going to start with. What I do next, second step that's in your method, we go to our dividend. So the part that we are dividing, use the coefficients only. So we're not using anything dealing with the variables. This is why this is a little bit more quick to use, I think. So just across the top, I have 3 coefficients, 1, 6, and 4, and I get those from here. Okay, here's how the process now works. And again, it does the same thing as doing a long division. I drop the first coefficient down, just 1. Think about what we do in long division. Next we multiply. -1 times 1 is -1. Okay. Think about what we then did. We added and subtracted terms together that were lined up. I now add 6 plus -1 is 5, and now I do the multiplication step again. -1 times 5 is -5, and then once again I add 4 plus -5 is -1. There's my remainder, just like I would have had before. So, final answer, the way we write our polynomial, is just like we did before. But here's what I do. If the original started as an x squared, think about what dividing x squared by an x would do. That would leave me with x to the first. So for the final answer, we reduce all powers by 1, and these are the new coefficients. So once again, this is our quotient, but I refer back to the original. So if the original was an x squared, this is now a 1x to the first. Just go right on down the line. It'll be 1x, and then we're at our constant term of plus 5. Last thing, just like the long division algorithm, we write the remainder minus 1 over the divisor, x plus 1. All right. So again, I'm sure you can see a little bit quicker and easier once you get rolling with the synthetic division part. Okay, we're going to do one more example of synthetic division. One more example of synthetic division. Let's see. Yeah, we'll do that one. 3x to the third plus 8x squared plus 5x minus 7 divided by x plus 2. Okay. So once again, to set up, the exact same thing we did in the last one. Again, you can, I would, if you want to, if you felt good with the last one, try this one. It'll work very similarly. Pause it, see if you get to what I do at the end. Once again, the number that goes outside of here is the root of this polynomial, which means it is what number, in this case added to 2, gives me 0. The answer to that is -2. Now again, if this were an x minus 2, I would leave a positive here. It would be 2 minus 2, which gets me to 0. The next part, once again, I fill in the coefficients across the top. So no missing terms. If there were, like let's say I were missing the 8x squared, I would once again want to fill in a 0 placeholder. For this one though, I'm all lined up and I have nothing missing. So I can go right through the process again. We drop the first coefficient down and then multiply. -2 times 3 is -6, and then we add in the columns. 8 plus -6 is 2. Multiply. -2 times 2 is -4. 5 plus -4 or -4 is 1. Last one, -2 times 1 is -2. -7 minus 2 is -9. So once again, if our original polynomial started with an x cubed, we reduce everything by a power of 1. So with our new coefficients in the final answer, this is going to be 3x squared plus 2x plus 1 minus 9 over the divisor, as always, x plus 2. Okay, so that wraps up the division section. What I will be doing, so along with this video, of course, just like the ones from the previous week, there will be suggested homework assignments to get a look at on Canvas. And as always, reach out to me with any questions, phone or email. So that'll be it.